Don't forget to like and subscribe. It's Jim Keller, everybody.
And welcome to Tech Poutine pre-show. Today has suddenly gotten very busy. For everybody who's joining, welcome. If you hadn't guessed by the title of the podcast today, a good chunk of it is going to be about Huawei. And because my Twitter has blown the top off, and I've just spent the last 2 hours responding to tweets and having thoughts, and reading AI-generated papers by Huawei.
Oh, that must have been fun.
That
for a given definition of fun.
Yes. And we're also now getting to the point where it's, how do you define density? And what does it mean to be, what is
that drove me up a wall.
And what does 10 nanometer class really mean? And what's this about standards, to the point where I'm actually getting replies from Chinese investors and Huawei Twitter warriors calling me a out of touch Western influencer analyst. Yeah. So that's still going on in the background, and of course, because we'll be on here for probably a good couple of hours. I'll have to ignore.
Probably closer to 3. Knowing us.
Yeah, we'll see.
And depending how deep we go, this may hit 3.5.
I have to keep tabs on my email because I have already had some Wall Street requests to talk about the Huawei situation. Because investors seems to be on their radar as well. That's not the only topic we've got to talk about today. George has been traveling, I have been traveling, and we will soon be traveling. And there's a bunch of other stuff as well, like a Cerebras IPO.
That happened. That happened while I was at Dell. Also, did you hear the news of the Sam Altman Elon Musk lawsuit over OpenAI?
I caught the smallest wind of it on a podcast that I wasn't paying attention to.
TLDR, since I don't think that this is one of our boxers, Elon lost, and the jury came out in less than 2 hours. The jury's verdict was that he took too long to sue. So my understanding is he invested some tens of millions when OpenAI was a non-profit. And then argued it should be turned into a for-profit company. They said no, and so Musk turned tail and went to do his own thing, XAI. And then in the meantime, OpenAI went for-profit. And so he came back and said, well, hey, you used my tens of millions of donations. I should get some portion of ownership of the for-profit company. And yeah, to George's point, the jury turned around and said no. You're too late. Yeah, and the thing is that the jury said, 1, statute of limitations, so he took too long to sue.
Yep.
And 2, the jury had also not off the record, but not in the actual deliberations, but spoken anonymously, that they would have sided with Altman anyway, regardless of statute of limitations, which is why it took less than 2 hours for the jury to come back.
Right. Okay. So, but yeah, because a donation at the point of donating is no longer your jurisdiction. As in, you relinquish claim to that money and the benefits of that money. Otherwise, philanthropy would be dead in the water.
Yeah.
I mean, there's the argument of OpenAI going for profit anyway.
Yeah, so. It's let's just say that
the goal of rich people is to make your money make money.
Yeah.
Not actually work. Other people work on your idea. And this is when we get things like Cerebras IPO and what have you. which made what 800 millionaires overnight. We'll get to it. It's interesting times. I tell you what, though, we're still waiting for people to come in, and because this is still the casual pre-show. I tell you what craving I had the other day. Domino's.
Why?
I don't know. There's just something about the consistency of a Domino's pizza that I probably haven't had in like 5 years. And I just
So while we're waiting for some people to come in, have you heard what's going on in Garden Grove right now?
I don't know what is Garden
so
Grove?
Garden Grove is a county is a city in Orange County, and currently there is a chemical leak at a methyl
Methylmacrolate.
Yes. Yes.
Try to trust the chemist to know what you're talking about without.
Yeah, I can't. MMA. That got too hot.
Mixed martial arts. But yes, methylmacrolate.
Yes, but it got too hot, and for about 50,000 people had to be evacuated.
Okay.
But it looks like, and I kind of just wanted, like, how dangerous is MMA? Like, in terms of, like, the...
Well, if you're in the octagon, very.
Mm-hmm.
I'm referring to mixed martial arts, that's the joke. So MMA, judging by the structure, sounds like it would be a very... If it's not a liquid at room temperature, maybe a solid, but it's sublimated. So it probably boils and sublimates quite low temperature, so it vaporizes pretty easily. Yeah, just like any other sort of volatile organic compound that's not an ester, is probably pretty bad for you. Ester is the type of molecule that we typically relate to smells. All the fruits that you commonly eat, or don't if you don't eat fruit, all the smells of fruits are esters, multi-chain esters. And it's funny how some of those smells the difference could be as something as simple as a methyl group and smell very differently. But methylmethacrylate, isn't that also a polymerizable material? You create plastics out of it.
It is used for acrylic plastic. By the way, Red Flames, is it the leak where no one knew about it because they only put the announcement out on X and Instagram? No, I am 60 miles away. I got a ping on my phone, like an alert that went, avoid this area. If you're within this area, please evacuate immediately. So no, everybody knew about that. And anyone saying that they only put it on X and Instagram is incorrect.
Yeah, it's the problem with those sorts of chemicals is it's one thing to enter the atmosphere, it's another thing to enter the groundwater.
The good thing is it looks like there's actually a crack at the top of the vessel. That was apparently designed to crack in case of overpressure.
Like pasta.
Yes, basically.
Okay.
And it looks like an explosion of the tank has been ruled out, and it's looking like what is likely to happen is it will likely just solidify in place, which is the best case scenario.
Yeah, it's put a cooling blanket on it.
They've been basically just spraying tons of water on it.
Okay. Would methylmethacrylate dissolve in water? Polar solvent? No, it's
I don't think so.
It's slightly polar. But I guess there wouldn't be enough interactions to make it dissolve. So
they're spraying the outside of the...
Oh, okay, as a coolant.
To keep it cool. And then I think what they've been talking about is dumping CO2 and basically freezing it. That Tweedle, the chemical, as answered, MMA or methyl methacrylate.
Let's see if we can show.
Not far off. It's not far off of a vat of super glue.
Yeah, methyl methacrylate. There's your methyl group, and there's your methacrylate group. And yes, it does say cooch. Technically, its real name is methyl 2 methyl prop 2NO8. If you're being exclusively IUPAC.
I could barely say methyl methacrylate.
So this is the thing. A project I'm going to execute on at some point is that people in here, I hope, know that my background is chemistry. And I still, you know, the fact that I can pull this up and talk about it means I still have, you know, interest in, at least in the concept of chemistry. And it was suggested at one point that because most of the audience is American and I am British, therefore I have accent, that I do a ASMR stream where I just reel off the names of chemicals. I have prepared something for this that could easily go to multiple hours. The question is, though, I wonder if it will load in time for me to show people. I have a question to put to you, and let's see if I can do a new do a poll in here. Stream just be ASMR, or should he explain the chemicals? LinkedIn user says, "No, I thought your background was computer architecture." Funnily enough, no. I am a chemist. Well, I'm really glad I did chemistry.
Neither of us have formal education in computer architecture.
Yours is closer to EE than mine.
Yes, but that's like saying that, like, simply because physics is closer to electricity than chemistry is.
Yes, yes.
Like,
okay, so this is a bit long. Okay, so this is the this is meant to be my thing. This is something I vibe coded. Don't hate me. Where I will show off chemical names. But the idea is, do I just say the names out loud? Like ribose, adenine, 1, 4, 7, 10, 13, 16, 19, 22, octa-azacyclotetracosane. Do I then explain what this means? And I've got,
just read the names.
And so I can tell you that those are aza parts in the cyclo. Or do I just go to the next? So this tris dimethylamino cyclopentadienyl lanthanum. I can go, well, it's you've got tris means 3, dimethylamino means you've got your 3 diethylamino. You know they're diethylamino because you've got the end, the amino group, and you've got 2 methyl groups on the end of it. Cyclopentadienyl is your ring here, followed by, you know, a 4-bonded lanthanum. And then go to the next. So do I read the name? And as Red Flames put it, refuse to elaborate further. So type 1 in the chat if you think I should just do ASMR. or type 2 if you want me to explain the names. But yeah, there's a. I vibe coded a thing with over 1,300 chemical names, and as you can see, here's an upcoming queue. The thing is, the story about this is I broke Google Sheets' AI rate limit on this. Google Sheets has a rate limit of 500,000 requests a day, and I broke it trying to build this because I was trying to get names of complex chemicals just for the lols. Nicholas asks, will I be using the same microphone? I've got a Shure high-end one here. It probably sounds better if I go closer to the microphone.
It does.
The problem is...
Actually, I should probably move my mic closer.
The problem is the UK is going through a heat wave right now, so I have an air conditioning unit on behind me and a fan that's in my face. And I
now have a choice. Do I move this big old keyboard and put that here and have my portable keyboard, or do I just leave it there?
Whenever you type, it's very obvious you're typing.
Can you hear it?
Yeah.
Really?
Yeah. Every key.
Okay, well, I guess I have to move this now. Sorry, chat. Hopefully the mic doesn't disconnect. So apologies if my mic quality suddenly goes down the toilet. So
yeah,
I put the big.
Yeah, my microphone might be a bit buzzy because I've got my air conditioning on. Let's turn it off for a little bit and see what happens there. My microphone is slightly louder. We upped it because George said I was coming through his a little quiet. So if I'm loud relative to George in general, let me know and I'll bring mine down a little bit. But yeah, it's George, your audio is gone. Or my audio is gone. This is why it's the pre-show. Nope. Oh, that's why. Can't hear you at all, George. Nope. Oh, it says you're muted.
Can you hear me now?
Yes.
Yeah, okay.
There we go.
This USB cable is really mangled at the end. So every time you move it. Yes, I know
mine does that when my cat lays on it and then nudges it. So, well, it looks like the people have spoken ASMR only. However, there was a few requests to say, and maybe you should do an extended version.
Yeah, I mean, yes.
It's I haven't set my thing to so you can define the seed. So each time you refresh the page, it's a different stream of chemicals. But okay, well, can we hide that?
Okay,
there we go. All good. We have
switching over to this as my keyboard so that I sound better.
So let's start today with a couple of simple topics before we dive in. Oh, actually, no, I'll get a full intro in first. There we go. So, hi everyone, and welcome to the Tech Poutine, the weekly-ish podcast where we talk about process and silicon and how we've taught very special rocks into think in very special ways. We're called the Tech Poutine because my name is Ian and I run a channel called Tech Potato, and my co-host is George from Chips and Cheese. If we had a guest, they would be gravy, thus making a lovely poutine. Also, if we had a sponsor, here's where we might put it. And I have had some requests for sponsorship, so those may be coming. So if you do wish to sponsor the show, do let us know. We do accept and read super chats, maybe our listeners and watchers, but only if they don't demonetize the channel. And the show usually sticks around for a good couple of hours, maybe more today, because I've got ranting to do. But stick around and we might get to some Q&A during. But today's first question is, George, how are you doing?
Good. Actually, my mother and I actually had breakfast at Blackberry Diner, which is where you, I, and Charlie went. For Marvel.
Oh, okay.
Remember the time we went
San
to
Francisco?
breakfast? Yeah.
I can't remember.
So my mother and I had breakfast.
I did my travel for last year, and I went on 53 flights, 91 days out of the office, 150,000 miles.
Than weeks in the month. Or
yeah.
Months of the year, excuse me. Or weeks of the year. Blah.
But that's not return. That's not 53 return flights. That's 53 individual flights.
Mm-hmm.
So, yeah, it's 80% of them were to San Francisco, to and from. It's actually cheaper from the UK to connect on the way back. So each trip is like 3. But yeah, it's been a busy couple of weeks. You've been traveling, I've been traveling, and we're just about to get ready to go to Computex.
Mm-hmm.
Looking forward to it?
Yes, I am, actually. I love going to Taiwan. But also, I think this Computex is going to be interesting. So I wonder what people are going to talk about. Like,
we're in a situation kind of like CES earlier this year, and kind of like Computex last year. It's incredibly mid-cycle.
Mm-hmm.
Nobody's got anything massive to announce, especially in consumer space. And Computex has, for the longest time, been a consumer show.
Mm-hmm.
This year, it's pivoting substantially.
I would say the last 2 years, it's been pivoting.
Most of the official keynotes this year are from companies that do not have end users as consumers. They have customers, but they're other businesses. So Marvell, NXP, Intel and Qualcomm have keynotes.
Mm-hmm.
ARM is doing their own thing. NVIDIA is doing their own.
Keynote. Yeah, but it's their own thing.
NVIDIA's keynotes at Computex always tend to be B2B focused anyway. Last year, people complained, why didn't you speak about gaming? And he said, well, if I spoke about gaming, it would be longer than 2 hours. And people turned around and said, well, you're at Computex. This is what we're here for. And you're speaking about the AI stuff? So who knows? We're not expecting any major announcements, launches of massive product lines, because we're still in this mid-cycle. AMD's got their Advancing AI event in a couple of months. But the back half of the year should be a lot more entertaining for that sort of stuff, which then leaves, well, what do you talk about at a show like Computex? And I think it's going to be a lot of those, how the tide is turning in certain markets because of machine learning. I mean, we already heard reports that motherboard sales are down. Obviously, consumer memory sales are down, but revenue is way up. So what does that mean? What are people doing about it? I did hear a report that said you can't be on the main show floor this year unless your main message is about AI. So AI mouse pads, AI glasses, AI screen protectors. But
AI cups, because we might as well make this an AI thing.
If it does mean that apparently companies that have been on the main show floor for 20 years have been relegated to the second building if they're not AI focused. There have been recent reports of commencement addresses at universities of the speakers being booed for mentioning AI. If they had said machine learning, maybe they'd have had a different response. The only one who wasn't was
computing.
Yeah, yeah, yeah. That's definitely a way around it. The only person who wasn't really booed was Steve Wozniak, because he said, "You're all here in the age of AI, actual intelligence."
Ah,
So, whereas Eric Schmidt got booed massively.
I mean, I was listening to it. I can't blame the students, honestly.
It's a big problem when you turn around to that group of people and say you can't use AI in your studies, but the future depends on it. It's like if we studied, people said the future of the universe is Wikipedia, but you can't use Wikipedia. It's
well, so okay. So I guess if we can get let's get into sort of the one of the topics. It's really the shortest one, the Dell Tech World. I was talking with Dell at Dell Tech World, and everybody, even at Dell, was in agreement. There's this AI like fatigue. It's the same
Malaise.
fatigue that we had with 3D back in the early 10s. Like 3D was everything. Like you saw 3D branding on a whole bunch of, not quite as universal as AI has been.
Yeah.
But you've seen like all the 3D everywhere back then.
Yep.
Right? HD was a big one. Back in the early aughts. Like HD was everything.
5G.
Actually, honestly, more 4G. Well, 5G kind of.
5G went a bit psychotic when people started burning cell towers.
Yeah.
And as people are saying in the chat, VR.
Yeah, VR.
Crypto.
But the thing is that all that branding disappeared, and then it became a tool, or it just became the standard.
Mm-hmm. If this industry is full of anything, it's tools.
That's what AI is going to become. Is that it's just going to become a tool that nobody talks about.
It's Nicholas in chat has a good point. It's about 5G being overhyped. It does with all of these tools, the hype reward effort ratio, it varies, between the VR and the 5G and the 3D and as you said, and HD. Everybody's pumping billions of dollars into AI and machine learning. So if the payoff it has to be as immediate, or the more that's invested in it financially, emotionally, the more immediate the payoff has to be. And that payoff is arguably why the software side is going so fast. Right. It's to be honest, with the topic on Huawei later today, that we'll get into, a lot of people have misunderstood a lot of things about it, and people have even been calling me out saying I'm misunderstanding a few things about it, where I'm actually being very deliberate with my wording. But as a result, it's causing stock prices to go up and down, right, massively on the Chinese stock markets because of some of this news. Because this is Huawei being more competitive against, despite being restricted by the US government and everything else. We'll get into that. There was a question in the pre-show about how do we manage investments and income tax, doing what we do, and the short answer is we don't.
That would imply that I make enough to file income tax.
George gets paid under the table. That's what he's saying. And I get paid £12,570. That's a zero rate tax brand.
Yeah.
So every builder in the country only earns 12,000. I file taxes. But yeah, it's that sort of thing. So you had fun at Dell Tech World then? You mentioned it. Let's talk about Dell Tech World.
So I will say, if you're ever invited to go, bring a pair of these noise canceling headphones.
busy?
because no, they decided to have live music at the keynotes, and it's really loud, like 115 decibels loud, and my ears are not used to that.
What?
It is stupidly, like, people's like watches were going off, like going like, it is too loud in here. And so if you ever go, bring headphones or like earplugs.
That's a health and safety. Did you? I assume people gave that feedback too.
Yes.
Okay, so Dell Tech World was in Vegas.
Yes.
And it's their annual everything
Event.
Dell.
Mm-hmm.
You know, it's Lenovo has one, Google has a couple. Obviously, we go there every year for CES. I've got a feeling that GTC might have to move out there eventually because of how big it is.
It wouldn't shock me. For anybody who doesn't know, Vegas has the most exhibition space of any city. Period.
It can handle 200,000 guests for a weekend. For an event.
It can handle more.
Well, yeah.
It can handle, I think, up to 350,000, and it has north of, I want to say, well north of like 10 million square feet of exhibition space on the strip.
But the thing is, these big OEMs, Dell, HP, Lenovo, are so big, and sometimes you forget how big they are. They can afford to have their own event for customers, for partners. George to go as an invited press. I've been to one or two Google ones. I don't typically work with OEMs in the way you do, so they don't invite me because I want to talk about hardware and they want to talk about software as a service on their platform or infrastructure deployments. So I don't. Last one I went to was Google I/O. That's where they announced Axion, the ARM-based CPU. Unfortunately, the event was about 0.5% Axion, 99.5% software. So I felt it wasn't. I didn't get enough out of it to justify going in the end. But also, I didn't write anything up about it except for Axion, and then my contacts with Google kind of filtered away. But did you have any fun at least?
Yes, I did. But I'll rapid fire a couple questions in the chat. Nicholas asks 115, how are you supposed to talk to people on the floor? This was during the keynote, so this is before the keynote. But yeah, I was having to shout to Marco, who was literally right next to me. Like utterly untalkable. That tweetle, like a live band playing? Yes. Yeah, there were live bands at both days for both keynotes, just spread across 2 days.
They didn't have AI music?
No, it was like actual live band.
To be honest, I've been at a Samsung event and they did Hi, Will I Am.
They had Keith Urban as the closing show. I was too tired to go. I just went up to my room and
I was like, isn't that an actor? There's like, no, that's Carl Urban. I don't know who Keith Urban is.
Nicholas says in chat, I'm surprised Vegas is the most well equipped. I mean, a whole bunch of casinos and hotels and Las Vegas Convention Center. It's not that shocking.
The hotels actually compete and bid on for conferences to go to that hotel.
Yeah, so, and then DYH Chang in chat, have you ever taken the Bright Line from Riverside to Vegas? That doesn't exist yet. The line from Rancho Cucamonga to Las Vegas is not built yet, and that's been delayed, and it looks like Bright Line is actually suffering monetary issues, so likely won't be built.
So what's the big news from Dell Tech World?
The big news, at least as far as they announced the Lightning file share and some new storage stuff, but they've been talking about that for a couple of years. They finally launched that proper. the thing that really interested me was Dell sort of talked about their 18th gen PowerEdge series. So this is their standard PowerEdge servers. And I talked to them about it. And now what's funny is that there's some information in this press release that wasn't actually said. So let's actually, if you want to open the link, the Dell link.
Yeah, I've got it.
Yeah, scroll down to the redefined compute and cooling. No, it was near the top. Up there you go. So the parts that I want to focus on is not the first three, but the last three. Specifically, enterprise consolidation, the Dell PowerEdge R9810 is a high-end single-socket 2U server powered by Intel's next-gen server processor, codenamed Diamond Rapids, delivering double the memory bandwidth, increased cache capacity, and up to 50% increase in core count with PCIe expansion.
Okay. You can increase core count with PCIe expansion?
Well,
isn't that just CXL?
The really funny thing is and at the top there, it says the 18th gen of PowerEdge servers deliver up to 70% better performance and 13-to-1 consolidation through advanced liquid and air and liquid cooling designs. Cool. Now let's scroll down to the bottom. Let's scroll to the endnotes after About Dell Technologies. Yes. Okay. Now, that 70%, I asked about this, the 70% number is compared to Turin against Venice. So that is 17th gen versus 18th gen, which is correct. If you look at number 5, that is in fact correct. But number 6,
AMD.
funnily enough, is incorrect. That 13-to-1 consolidation is not against Turin, it is against Cascade Lake and the generation of servers at Cascade Lake, which I believe is 14th generation. So there's a typo there, and it's Cascade Lake to Venice when I asked. So
consolidation, but every new generation of hardware does that.
Yeah, for a comparison, Turin was 7-to-1 consolidation. Venice is 13-to-1 consolidation versus Cascade Lake.
I think this is a slide you gave me.
Yes.
Instead of having 1,000 servers, you can have 131.
Yeah, and then it's 1,000 servers to, what is that, 70-ish with 13-to-1 instead of 7-to-1.
Yeah.
Now, going back to the endnotes, number 7 is funny because it says the Dell PowerEdge R9810/9820 delivers memory bandwidth up to 12,800 megatransfers per second, doubling the 6,400 megatransfer capability of the previous 17th gen PowerEdge servers. This represents a 2x improvement in memory bandwidth between generations. So the funny thing is, yes, Diamond Rapids is, assuming the 12,800 megatransfers per second is correct, yeah, Diamond Rapids is going to be about double the bandwidth of Granite Rapids, but that isn't from a doubling of the DIMM bandwidth. Well, clock speed, effectively, really. it's coming from an increase in number of lanes from 12 to 16, but that 12,800 number is actually coming from MRDIMM, because JDEC only goes up to 9,200. It's
So it's
the MRDIMM
MRDIMM
value,
enabled. Yeah.
which on Granite Rapids is 8,800. So it's really 8,800 12 channel to 12,800 16 channel. So
That's where the 2x, yeah.
yeah. Now, number 8 is also interesting. The PowerEdge units equipped with Diamond Rapids P cores delivers 50% more CPU cores than the previous generation. Well, Intel Granite Rapids P core CPUs offer 128 cores per socket. Diamond Rapids scales to 256.
It's 100% more, isn't it?
Dell, yeah, that's 100% more, not 50. Also, that's confirmation that Diamond Rapids is 256 cores, not 192 or whatever was being talked about before. So, but yeah, I just find it very funny that they say 50% more CPU cores, but it's actually 100% more.
It's weird, right? Because I've seen this before. Sometimes OEMs, they'll compare a single socket current gen solution to a dual socket next gen solution.
Yeah.
And they'll make the numbers up that way. So,
Well, and if you said 50% less sockets to achieve same core count, that is technically true, because 2 sockets to 1 socket.
Yeah, it's the problem is, once you get given this and you start noticing the errors, it's hard to take the rest of it seriously. But you got you spoke to a bunch of contacts while you're at Dell Tech World.
Yeah.
Does that mean you're going to get access to more stuff?
I hope so. That would be cool. I hope that whenever it arrives, I managed to get a hold of the Clearwater Forest system, just because, like,
you managed to get hold of the person who will give you a system or get you access.
I'll have to reach out to Papa.
It's Clearwater Forest is due out soon, isn't it?
Well, it's been due out soon for a while.
Clearwater Forest for
that's something that Intel talks about at Computex.
For those that don't know, Clearwater Forest is the eCore server platform.
Also, that is
Sierra
Tweedle.
Forest.
Your number is wrong. It's actually a 33% increase, going from 192 to 256. That's a 33% increase, not a 50% increase.
Yeah, and Nick asks, has Dell done a design for CAM-based MRDIMMs? It's still the memory manufacturers who are making the SOCAM DIMMs for enterprise, and I don't believe they're MRDIMM supported yet. They're still just DDR5 8800, and I think they're actually slower than that.
So for CAM modules, there's DDR5 support.
No, I'm talking about SOCAM for enterprise.
SOCAM is LPDDR currently.
Right.
It's only LPDDR5X. No DDR5.
No, and you can't get MRDIMMs on a consumer platform. So there is that. So Dell Tech World, and then straight into Computex. So now that we've been online for 45 minutes, let's get into the topic that's taking me. So let's read the prep statement here. Huawei shocked and surprised journalists when it announced that it hopes it will be able to make 1.4 nanometer class chips by the end of 2031. This is without access to EUV or new equipment due to export limitations and US sanctions. Huawei has proposed a new Tau scaling law, or DAO, depending on if you want to go into some Chinese culture, that replaces traditional geometric scaling or Moore's law. One of the techniques that they've shown in a recent talk at a conference, this is why this is all kicking off, is called logic splitting. And we've already seen from other companies that, such as AMD, that there has been a roadmap of advanced packaging and scaling that we know this has been on the cards. Other semiconductor companies are looking into this, but due to other lithography tools, namely EUV and high NA, enabling logic scaling, things like logic splitting are on the back burner. Now, with Huawei's inability with SMIC to get anything more than modern DUV equipment, there is an effective scaling wall. Without excessive patterning, which has risk for misalignment and contamination as well as other factors, SMIC and Huawei cannot feasibly get below what TSMC, Samsung, and Intel Foundry have been called 7 nanometer. Can they do it reliably? This is yet another iteration. But during the keynote in the talk, Hating Bo, the person giving the presentation for Huawei, announced that in the last 6 years they have mass-produced 381 chips in different sectors using this Tau scaling philosophy. Though what was interesting is that the Kirin chips to be released at the end of the year will apparently be using this logic splitting, or what they're calling logic folding architecture already. It remains to be seen whether it can be done at scale. Well, that's what we had in prepared remarks. Let me bring this to the stage. This is the tweet that I think a lot of people saw. I mean, look, 31.7 million views. This is Tingbo He from Huawei. Huawei presents that. So it's three things here Huawei presented, and it's important that you understand that they are distinct parts. One is the Tau scaling law, and we'll get into that in a second. One is that they, through the method of the Tau scaling, by 2031, they will have a transistor density that is equivalent to 14 angstrom processes, which is still going to be a couple of years behind everybody else anyway, if you assume that to be true. And the third one is this logic folding, logic splitting technique, and we'll get into each of them. This is the tweet that most people saw. And then this is the official press release on the Huawei website. So I'm not sure how many people were briefed on this, but people are rushing currently to get articles out to explain what this means, and there's a lot of FUD everywhere. So let's start with the Tau scaling law. I believe that image might have been deleted from this thing already. Let me get it in here. It's annoying when it. Right, yeah. So this is the Tau scaling law, right? Now, to put this into perspective, Moore's law, whether you call it a law or whatever, Moore's law is seen as a target in the industry to improve logic scaling. Now, you can interpret the law in many different ways, and people vehemently argue on this, and I've covered this before. But some people see it as a doubling of transistor density every certain amount of months and years. Some people see it as a increase in the number of transistors per chip. Some people see it as a number of transistors per package. And some people see it as a economic law, right? As in it's all to do with transistor cost over time. Those are the four main ways to interpret Moore's law. I'm of the opinion that it's transistors per package, because I find that as a useful tool to drive the process forward. Now, the thing is, Moore's law isn't the be-all and end-all, right? There's more to just simply improving your transistor density. There are things like packaging and design technological optimization, and TSMC has a thing called FinFlex, where you can decide how many transistors are on your PMOS versus your NMOS. And you optimize different VT voltage, temperature, voltage, frequency targets for your cells, right? And there's a whole array of techniques that we kind of all bundle under Moore's law because it gives a common view. Huawei's opinion because they no longer have access to the leading edge EUV and high-NA EUV because they can't use TSMC or Samsung or Intel because of US sanctions, is that we need to redefine what our goals are. And their argument is that we're going to redefine this by ignoring Moore's law because we can't compete with that, still acknowledge it exists, but talk about tau scaling or Dow scaling, or again, and tau and Dow in China has relevancies. But the whole point here is that if you can improve your silicon in any way, the device, the circuit, the chip, or the system, then you are following tau scaling. So it doesn't matter if it's just logic density. It could be SRAM density. It could be efficiency. It could be capacitance. It could be DTCO. It could be 2D. It could be 2.5D. It could be 3D, right?
But that applies to
yes, it applies to everything.
Yeah.
What they're trying to say is we think Moore's law is too narrow focused. Yet Moore's law has been a proxy for everything I've just said for decades.
Yeah, you're fundamentally just trying to you're redefining a term in such a way that you're not changing the definition at all.
And this is what Bloomberg calls a breakthrough. Yeah, a lot of media organizations have said that Huawei have turned the tables on Western chip design because they're doing tau scaling rather than Moore's law scaling.
It's the same thing.
It's literally the same thing.
PR. Corporate wants you to tell you the difference between these two pictures. It's the same picture.
To be honest, let's get a meme of that and a T-shirt out. I say Bloomberg because I did see their article, but a lot of other news outlets are saying this is revolutionary. This is, and I've had an argument on this with Twitter with a couple of Chinese people already, saying, your Western brain is too small to comprehend. It's not. It's just redefining the problem is rarely a breakthrough, right? And in this case, we know it's not a breakthrough because this is stuff that people have been doing again for decades, right? Logic scaling has been a part of that. Their whole argument here is let's focus less on logic scaling and focus more holistically at a system topology. And yes, Bloomberg also had that issue a few years ago with Supermicro. But this is all that slide says, is we're considering tau scaling to be everything. And so when they say we've developed 381 chips over the last 6 years in different sectors using this philosophy.
By that definition, there's been millions of chips developed
by this philosophy.
Using that very same philosophy.
Yes. So it's don't go wrong. Clever marketing. And if I was advising Huawei, I would say this isn't a bad idea, but perhaps be a bit more humble about it, because you're not redefining the view, you're refocusing the view, right? So the tau here is meant to be time, and it's time to solution rather than transistors per square millimeter or frequency
when I heard
cost.
When I heard tau scaling, my brain went to time scaling.
Yeah.
Like what?
It's 2 pi scaling.
yeah, that's exactly what it is.
That's the T-shirt we need to make. It's got 2 pi's on it. It says tau scaling.
Oh, that's good. That's good.
I'll fire up my AI models. Yeah. So that's tau scaling. Yeah. The next thing is this circuit folding that they're doing. What they call it, logic folding architecture. Again, logic folding, logic stacking. the best way I want to showcase this is by actually using AMD's slide. And I'll take the comments off the stage just so we can see it for a second. And AMD showed this slide off, I think, in Hot Chips 33, which is back in 2021. Mm-hmm. And this was at a time where the concept of stacking chip on chip was just starting to become reality, right? Already been in the works 10 years, right? EMIB, the initial thoughts and patents filed in EMIB were, I think, back in 2008, right? And EMIB is a form of stacking technology, right? So 3D stacking, you know, this isn't pop stacking, right? This isn't 45 micron stacking like with CoWoS. We're talking about here hybrid bonding. What typically is called hybrid bonding or HBI, where
what AMD now uses in Vcache.
Yes. So the way this happens when you have copper bumps, or they're not bumps. It's just copper ends that you bond together from two chiplets. The idea is you do it without balls, so you can get the pitches finer. And when it's using balls, we just call it, you know, balls on balls bonding.
Micro bumps.
Micro bumps. There we go. But I'll keep saying balls on balls and laugh every time because I'm 9 years old. But hybrid bonding doesn't use the micro bumps, and it's a way to get denser connections, but you need to design for it, right? And the first productization of this, just to clear up, Intel's Foveros, the first and second generation are micro bump because they're 45 and 35 micron pitch. AMD's first Vcache, and therefore TSMC's first hybrid bonding, is 9 micron pitch. That means the distance between the center of two connections is 9 microns. Yeah, and when we talk about 10 nanometer, it's obviously 10 nanometer is very, very small. So 9 micron by comparison is huge. But it's a way to combine chips together. And as we see here on AMD's diagram, you know, with 9 micron pitches, you can do RAM on CPU, CPU on CPU. That's full die to die. And then they're going down here in the how interweaved can you put your design together. So going down, we've got IP on IP, and then macro on macro, where we're literally splitting up different parts of the CPU core onto different chips. IP folding and splitting, where you're doing even individual parts of the IP blocks until we get fully to the end circuit slicing. Now, as you go down, you need finer and finer and finer pitches. You need smaller and smaller micron-sized pitches. And the reason why that is because every time you go over one of these connections, you encounter a resistance and capacitance, and you have to overcome that. And the way you overcome that is by more and more connections running at lower and lower frequency, right? And in terms of roadmap right now, AMD Vcache is at 9. Intel's Foveros Omni, I believe, is at like 9 or 8. And Samsung is doing Samsung things. Samsung doesn't do a good job marketing there, so we'll leave that for a second. Both TSMC and Intel have roadmaps down to 6, 5, and 4 micron pitches, right? In research, we are down to 100 micron, or even 100 nanometer, even tens of nanometers in terms of bump pitches. The biggest problem between research and productization is moving it into volume. Because you can do it once in a lab, fine. Doing it 10 million times in a facility is problematic. So not only that, you need the tools to do it.
Well, for example, there's a 2018 paper, first demonstration of 3D stacked FinFETs at a 45 nanometer fin pitch and 110 nanometer gate pitch technology on 300 millimeter wafers. They were literally 3D bonding the FinFETs together.
Well, so that's even a technology that's coming further down the line.
Uh-huh.
It's called complementary FETs.
That was being done back in
2018.
Uh-huh.
Yeah. The thing with volume manufacturing though is the lithography to do hybrid bonding is very different to standard leading edge lithography. One example is I was at a show last week, where ASML presented some of their hybrid bonding solutions, and the amount of energy you need to hybrid bond is per square centimeter is 10 times more than you need for leading edge EUV 2 nanometer transistors, right? There's a lot of energy that goes into this. You got to, which means the fact that you're putting more energy in means that it's also slower, right? Because energy is a function of time in these processes. And then you've got to yield it at scale. You've got to bond it at scale. Are you doing, when you're bonding dies together, because this is all die on die, right? Do you test each individual die? Do you do singulated die tests like Intel does, so you know you're putting a good die with a good die, or are you just freeballing it? Are you just taking any dies that come off and bond two together and see what happens? Or are you testing to make sure each die is work, so you put good with good and you can throw out the bad at that? So logic stacking from Huawei is 3D stacking in the conceptual sense, but instead of having SRAM on logic or logic on SRAM like we have at AMD, their purpose is saying we're doing logic on logic, and we're doing it at a 2 micron pitch, which would be market leading significantly. And so I'll throw up a couple of slides here that we have from the presentation. If anybody has access to the full presentation, please let me know. I'm still only getting rough slides. So what they're saying here is that their smartphone chip, so this is a Kirin smartphone chip for 2026. We expect it's their leading edge chip, is going to be using this 3D stacking design. What they're calling, they're saying that logic folding is one step beyond 3D stacking. Going back to the AMD slides, this is essentially going from the second one to the third or the fourth one. We expect it's more likely to be the third one because you need, nanometer size gate pitch for right here at the end. So what Huawei is,
I'm just going to say it. Like, I very much doubt that this is that. Like, that this is macro on macro. I have a sneaking suspicion
it's just IP on IP.
Yeah, that this is IP on IP, and that their plans for the future are two micron bump pitch, macro on macro. But what they are announcing and releasing later this year is actually going to just be IP on IP, and it's probably going to be
it's just
at a lower bump pitch.
Yeah. So going back to this slide, what they're saying here is that with the Kirin 2026, they can increase max frequency, they can increase their P-core power efficiency, and that's fine because you can do chiplets of different process nodes. We get that. The max frequency we'll get to in a bit. The density here is annoying because what they're doing is when we talk about transistor density, which is often a proxy for the quality of the node, we're talking about transistors per unit area, not per unit volume, per unit area. And that's what we're calling a density. It's a metric that has existed from the beginning of making chips because pretty much every chip we make is monolithic. Even today, pretty much every chip we make is monolithic. The problem becomes once you stack logic on logic, because your total 2D space is now 2 layers, but your physical XY dimensions of the chip have stayed the same. So if you're saying transistors per square millimeter, are you talking about the floor plan or the silicon used? And the thought experiment I put on Twitter was, if you build a bungalow, a 1-floor house with 3 bedrooms, that means you have 3 bedrooms per unit house. If you now build a second story on that with another 3 bedrooms, has your density increased?
Depends.
The correct answer is, in urban planning, yes. In construction, no.
Mm-hmm.
And what Huawei are doing here is the urban planning equivalent, whereas the rest of the industry
False
is
the
construction.
construction method.
Yes. So,
Because, like, for example, so I don't think this is a shock to anybody, but
I'm going to
also
go grab a prop or two.
Okay. I also write for Tech Insights, and whenever Tech Insights does a transistor like density measurement for Vcache, for example, they will do a density measurement for the top die and a density measurement for the lower die. They don't. Granted, that's logic on SRAM, not logic on logic, but the same thought applies where it's really the density of the dies individually, not the combination of the two.
Can you hear me?
Yes.
Okay. So here's my prop. Here is a Microsoft fungible ASIC. Back when they used to do smart network controllers back in 2019, right? Imagine this has 50 million transistors, right?
Mm-hmm.
If I put 5 of them together, do I now have a chip that's 250 million?
No.
Or do I have 5 chips of 50?
You're 5 chips to 50.
So this is the argument on the transistor density, right? It's yeah, no, these are like $3 each off of Tmall. So I decided to get a chip that says fungible. My camera's focus, but yeah. So that's the problem I have there. We also have.
Do you want to talk about the paper?
No, not yet.
Okay.
For some reason,
is that in the third one?
Disappearing. Do my images keep being deleted or what? So this is a diagram in the presentation talking about circuit folding, about logic stacking. There are other problems you have. So one of the reasons why it probably is macro on macro is because you have to do timing synchronization between layers, right? And that's difficult. It's difficult to do it in a big chip to begin with, in a big chip. So if you suddenly have synchronized between layers, you have to decide, about your phase lock loops, about your buffers, your transmitters, your receivers, about your skews. And here they're saying that by doing some clever jiggery pokery, you can put data paths in the top and power in the bottom, and that reduces your footprint and things like that, which kind of sounds like power via a backside power delivery. To maybe they're taking this all for a joke, and this is just backside power delivery, but called 3D stacking.
Oh my! If that's the case, I'm going to lose my mind.
Yeah. I need to make some room because, again, more images. Okay, so how do we know it's 2 micron? And it's from this picture that somebody sent to me. Currently, with all hybrid bonding solutions, because of the capacitance and resistance and the extra time needed to cross that boundary, they're not on the critical path. And by critical path, we're talking about the fastest way to get to a solution, to a compute solution. Huawei is saying that through fan out, they're able to reduce their hybrid bonding pitch to sub 2 micron. Now, that's not to say, as George pointed out, that this is coming in the Kirin later this year. This might be simply the end goal. But this is what it has to look like, and the pictures you might see are very much of this ilk, right? But if you can see, when we're doing, the interesting thing here is, this is logic on logic, right? The hybrid bonds appear at the top of the metal stacks.
Mm-hmm.
So what you've got here is a back-to-back.
Yeah, not a front-to-front.
Or a front-to-back.
Yeah.
So where's the power being dissipated? At the top and at the bottom. And you've got the latency of the data to go all the way through the metal stack, all the way up to the top. That might be negligible. It's something to look at.
And the thing is that the reason why TSMC and Intel want to do front to front is because then your critical path is not that long loop. It's right next to each other.
Yeah.
The
end result is they showed this, right?
Okay, but before you say anything on that right side chart, to quote our good friend Felix, what type of flops?
Oh, it's just assume FP8 at this point.
No, assume FP2.
MXFP2. So here they're showing their transistor density versus their systems roadmap. And now there is some jiggery pokery on the density measurement. It is design utilization of 60%. But the jump here is 2025 to 2026. They're saying that their P-core frequency goes from 2.75 to 3.1. And we know that's been a limit of SMIC's 7 nanometer technology. Huawei's not being able to get above 3 gigahertz on it with their cores. The density here goes from 155 to 238. Again, because we're stacking 2 chips, bro.
Mm-hmm.
That's not the same thing as density. Come on. Some people will argue if you read down here, it probably does take that into account, but I doubt it. What they're saying
Apparently, there are more details and better slides on Huawei's live stream that they stream to YouTube.
Okay, I'm going to have to go through that. So, but you also notice that 2030 to 2031 is also a significant jump, not only in frequency, but also in transistor density.
I'm wondering if that's when they're going to be doing the 2
micron. Yes.
Yeah.
Yeah.
But also, if you look at that density equals 2. That's not a standard measurement.
No. To be honest, density is a non-standard measurement for everyone.
Well, isn't it just gate pitch
No.
time? No.
No, everybody has
Okay.
their own. I remember Intel tried to redefine transistor density by talking about ratios of flip-flops to other sorts of gates. So it's that sort of thing. And then we come to the paper.
Oh, I know you had some words here.
Let me share a link to the paper in the chat if I can just find it for a second.
I actually have a link here.
I haven't been on Twitter for a little while.
Give it to you. Here you go.
Where are you sending it to me?
Discord.
Okay. Yeah. So this is on China's version of Archive. So it's also a presentation at a conference. So it's not peer reviewed. It's not a massive paper by any means. It's 16 pages. It's fairly high level.
Fourth line down, I'm noticing a red flag here.
So I started reading this, and I think I got to the end of the first paragraph, and I noticed something very peculiar. And this is something you notice if you work with it a lot. Now, I'm no stranger to AI. I use it as an assistive tool in a lot of what I do. I'm mostly shouting at it and telling it it's doing things wrong. So when the AI lords rise up, I'll be the first to go, no doubt. But when you use it as an assistant to writing a lot of things, you identify very specific ways in which things are written. That's a really shitty sentence. You understand how it writes things. And one of the ways it writes things is, everybody knows about the M dashes at this point, I think. Everybody who's deep into it. The M dashes, which are the super long dashes, actually a common thing in Mac word processors. If you do a dash space, it will do an M dash for you. But for some reason, GPT and other LLMs do a lot of M dashes. What they also do is a lot of short, stabby sentences. And so let me read it to you, just so you can identify the short, stabby sentences. For 6 decades, Moore's geometric scaling drove progress in semiconductors. The industry compact no longer holds. Returns from pure dimensional shrinking have flattened. Leading-edge design budgets exceed $1 billion per chip, and cost per transistor at the most advanced nodes is no longer falling. This perspective argues for a successor scaling principle, tau scaling, that adopts time itself, rather than transistor area, as the primary metric of progress, applying a single characteristic time constant tau as the unifying optimization target across 12 orders of magnitude, from a switching transistor to a data center workload. It's a short, stabby sentences.
And as a Brit, you would know a lot about stabby stuff.
Yeah, yes, we call that Wednesday in London.
No, but another thing that you could tell that this is written by an AI, because I've used ChatGPT as like for editorial pass before, just because I know that I can be very long and rambly in my sentences. Lists starting with a colon, lots of those.
It does like multiple sentences that have the A, B, and C format. Yes. That's another characteristic, probably derived from having short, stabby sentences. It also enjoys doing what I call false binaries, which is it's not X, it's Y, or phrases of that nature. It's not that we can't see this, it's because of this. It's not because it didn't work, it's because it did work. For example, I'll read on. This is just a screenshot, but it says, for Huawei Semiconductor, this transition arrived with additional constraint, restricted access to the most advanced lithography tooling. Assuming that another node would resolve the problem was no longer tenable. 6 years ago, the geometric roadmap plateaued, forcing a more fundamental question, one that, in retrospect, the entire industry will eventually have to confront. I mean, that's just all 4 of my big AI talking points all in one, right?
Uh-huh.
It's now, somebody did point out to me, maybe this is just because they wrote it in Chinese and they used an AI translation tool. The thing is, when you do that, sometimes there's still mistakes. I haven't seen a English mistake in this. It uses a lot of words that AI likes to use. I'm pretty sure you've seen the graph of scientific research papers with the word delve in them has tripled in the last 2 years, because delve is a very AI phrase. Let's delve into this. Things like plateaued, especially as well. And the thing is, because this paper is talking about some basic, we saw with the tau scaling that it was pretty holistic, but they tried to put numbers to it, right? it's a similar sort of thing in the research paper. Let me reload that image.
I have noticed a typographical error. I have multiple, actually.
Yeah.
Yeah. So there's no separation between the sentence after integration by 2035, and then there's a double space earlier.
Oh, you mean between single and double spacing? Yeah.
Yeah, it's inconsistent at points.
It's yeah. So it's that yeah. Actually, let me see if I can bring up just this the screen for a second. Window. I read PDFs in Firefox because it's a lot easier. So LogicFolding. So up here is the SoC list. I've always advocated that chips should be called by the year they come out. Unfortunately, like cars. But apparently nobody seems to like that. But LogicFolding at a glance. Hybrid bonding pitch is sub 2 micron. So 1.5 micron in 2026. That's crazy. That's market leading, if true. Overlay accuracy. So this is the how accurate can they be getting, because what they'll probably do is chip on wafer or wafer on wafer bonding, then dice, rather than chip on chip.
I would assume it's wafer on wafer.
Yeah.
The wafer on chip is also, or chip on wafer is still possible.
It depends. They've not said anything about whether the chips are the same size. Right? But this overlay accuracy is essentially how accurate can they get it. And you need it to be small enough such that regardless of how big your hybrid bond is, you'll always be in contact substantially. Because the less you're in contact, the higher resistance you are. Failure rate of 100 parts per million, repair rate 99.9%. So what they're saying here is that they're building in enough redundancy, so you don't just have one data line, you have 4, sort of thing, just in case it's all screwed.
Yeah, that's fairly standard. But I will say an overlay accuracy of, considering that they're saying under 0.5 micron, for a 1.5 micron pitch bond, under 0.5 seems high. I would expect under 0.1.
This is where the failure rate or repair rate and redundancy comes in, because you expect all of your bonds to be in a specific XY location, but they might be plus minus 10 nanometers. So imagine, it's like it's like when they built the Channel Tunnel from France to the UK, right? There was a margin of error, and I think the margin of error was probably as a function, as a fraction, worse than this. But you try and do it. That tweet all said 100% yield ? This is just the hybrid bonding yield. Nothing to talk about frequency or shmoo plots yet, right? So again, are they pre-testing chips? Yep, and we have they've got a new interconnect to deal with this hybrid bonding, and then also at a later point they're going to put in optical I/O, which again isn't groundbreaking. Optical I/O has been considered part of the let's move forward with Moore's law sort of thing for ages. It's because now they're saying tau scaling is everything.
Ah, wonderful. Okay. I'm about to send you a link on Discord. real quick.
The n squared versus n dilemma, because we can't calculate density properly.
So you know Colonel on Twitter?
I probably recognize the picture.
So, okay. Actually, I'll just send you this image, because this image, and then
this is a comparison of
yes. So this is using their own formula, and that's roughly where it sits.
Okay. So yeah. So in reality, they're actually showing 30 to 40% higher number than they're actually getting.
Yes.
And so it's the equivalent of a Intel 10 or TSMC N7. Okay. And there's one thing that hasn't been addressed at all in any of this, and that's thermals. One of the main issues of logic on logic is you're putting too much complicated stuff together, right? And now, if you're dealing with, say, 40 nanometer, maybe you've got more headroom, but your performance is terrible because it's 40 nanometer. If you're dealing with TSMC 7 nanometer equivalent, maybe you have thermal headroom. But as we said, if the bonding is back to back and you've got the compute on the top and the bottom of the two die, again, two die, instead, let's turn this one around, and so you have the heat on the top and the heat on the bottom. How are you cooling that? You know, do you want to look into microfluidics? Well, IBM has all the Western patents on that. You just copy them, I guess. But it's a smartphone chip.
Yeah. It shouldn't be that power hungry. Sustained.
Well, no. So that's the chip as a whole, right? The problem isn't the peak consumption of the chip; it's the hotspots.
Yeah, it's
right.
The ALUs, it's the SMAs, it's all those pipes.
It's you know, if we go back to our AMD image for a second, when you've got macro and macro, or anything macro and macro left, when you design a 3D stack chip, you have to be cognizant of what is on top of what, because you need the thermals to work. If you put high compute on top of high compute, you're screwed. This is often why critical paths are difficult to do in 3D stacking, because a critical path just goes straight from the bottom to the top. From the bottom, it's on the transistor on the bottom to the transistor on the top. That's why IP folding / splitting and the circuit slicing is very, you end up with a very thermally dense solution, because you're now putting, 200 transistors instead of it being in a 2D block into a 3D cube.
And actually, again, AMD gave at a synopsis thing, a presentation, gave a really good talk about like how they had to do thermal design. Because, so fun fact, apparently MI300 was actually designed using thermal rules of thumb, like not even like computer design, because the tools didn't exist at the time.
To be honest, they still don't. Right.
Well, they've started to become developed, like 3D blocks from Synopsys. But my point is that
Cadence announced that their Virtuoso platform in the future, using machine learning, will support multi-die design rules. And so you can split your chip, your macro and macro across multiple dies. But again, you have to, thermal design in a smartphone with hotspots. So somebody said, well, couldn't they just use a MEMS cooler, because they're, all the rage. MEMS cooling is fun, but the efficiency is what, 85% at best?
Yeah, which is not at all sufficient for a phone.
So if for every 7 watts you cool, that's 1 watt of power you need to power your cooling. The point is, you have to think about this in terms of a smartphone. If you're in an automotive device, then pack it in some sub-zero thermal lubricant, whatever. But in a smartphone, you're not. And 3D stacking logic on logic is hard. At 2 micron bump pitch is going to be hard, and so far they've not addressed the thermals on it.
And so in chat, Maymon7831 says in the live stream, in the Huawei live stream, they mentioned thermals as part of future challenges. I'm sorry, Huawei, that's not a future challenge. That's a now challenge. If you're going to be doing the 3D stacking, that is a now challenge. Again, referencing AMD, there's a reason why they went from logic on or SRAM on logic to logic on SRAM. Heat and removal of heat and all this fun stuff. Like
it was the thing is, putting the compute on top is actually more problematic because you've got to put all the power through the bottom chip. It makes all the communications to other chips longer and delayed. I've got a video on this. Like why I wanted to call it the Australian CPU because it's upside down. But there's many reasons to not do it that way. The only one being relevant is thermals. So if I can share this, where did it go? We actually did an article on more than more about putting HBM on logic, and HBM4 has a logic die on the bottom. So you're putting logic on logic before you're putting it into memory, and this is research TSMC has done, right? So instead of doing it in a 2.5D like this, you put it on top 3D like this.
And actually, Moshi, good friend of both of us in the chat, says, no, you also don't get the cost savings of node scaling if you just slam 2 dies together to get the increased density numbers.
Yeah. Well, that might be why it's not a double, because one chip is on an older process node, right? And again, it's not true density. It's just transistors per chip, per package. But yeah, no, if you just plonk 4 HBMs onto a compute die in this scenario, you suddenly have thermal hotspots at 140 degrees.
So actually, one of my favorite people to talk to at Dell, Travis, was talking about the cooling. You can find images of it, but the cooling apparatus for their Dell Pro Max with GB300. I wish the name was better, but anyway, is a single unit, right? But the important bit is that they actually cool. You would think that you would cool the GPU die first, but they don't. They cool the HBMs first because HBM actually has a reduced max temperature relative to the logic, right? Think of laptops. Yeah. They can go up to like modern Apple laptops, 115C, and they'll happily go up to there. But HBM usually tops out around 85-ish.
Yeah,
I believe is a spec. So
in this paper, they said, well, if we do a bunch of stuff, we can get the temperature down to 17.8 degrees, right? Which is standard. One of the biggest drops that they had was, one, merge the HBM together. So instead of 4 dies, you have 2. And the other one was frequency scaling. Cut your frequency by half. The easiest way to drop the temperature is to drop the frequency. And Huawei has already said we're not dropping the frequency. So, yeah, how to cool the 3D GPU stack on fire? Well, how to cool your smartphone on fire? Now, it's
because realistically, you have at most 3 surfaces to dump heat into in a phone. You have the back cover, you have the screen, and you have
the human.
The outside. Well, unironically, that is actually one of the heat sink. Like, sinking heat into a hand from the sides is a tactic that you can do.
Yes.
It's just you can't do a lot of that without causing problems, right?
Mhm.
Because while your body will liquid cool the phone via your thermal interface material, that thermal interface material is not very efficient, nor is it insensitive to significant heat.
Yes. It's the problem that this whole story has is not that it's unbelievable, right? This whole thing about, logic bonding, logic splitting, what have you, has been on roadmaps forever. The fact that tower scaling now just encompasses everything rather than just logic scaling isn't changing anything, right? Another thing, the big breakthrough here is Huawei claiming sub 2 micron hybrid bonding and logic on logic. Now, I did have this argument online a little bit, the yield issue, right?
Mm-hmm.
They've said that their hybrid bonding is effectively 100% yield because they've got failover and what have you. That's fine. But when it comes to building chips, if they're using the same SMIC process as they've been using before,
Mm-hmm.
then that's probably very well known and they can yield a good 80-90%. If their bonding on top of that is 100, then their overall yield is, again, and all it means is because they haven't had access to logic, they've decided to pull on one of the other threads a lot earlier than everybody else.
Mm-hmm.
You still need to scale that in terms of manufacturing. So somebody pointed out to me that Huawei made 40 million smartphone chips last year for their high-end
That's
devices.
not a lot. 40
for SMIC.
So
Don't forget they make data center chips as well, so that comes into the volume of the foundry.
true,
Right.
But
It still means
okay.
that if they're going to sell the equivalent this year, they need to hybrid bond that many. Well, they need to first make twice as many chips, assuming it's just 2 stacks, not 3.
If you think about it, how many?
And also hybrid bonding machines.
I realize SMIC versus TSMC or Samsung themselves, but how many S24s or S25s or S26s with the latest Qualcomm or Exynos chip are sold? And that's just one device.
Mm-hmm.
It's not including iPhones. It's not including. So that's why I say that seems low in my head.
Well, so one of the biggest companies in the hybrid bonding space is a company called Bessie, right? And everybody's tracking them as a marker on leading edge equipment. And I believe that they can't sell to SMIC.
No.
Right? Because my question is, who's the Chinese equivalent of them? And how have they gotten so far ahead? Now, again, you could just argue because they haven't focused on logic. They've just put people on something else and they've just solved it quicker. Right? If there's one company that is willing to accept lower yield, higher pricing in order to get massive volume, it's Huawei because of who backs Huawei. But also, Huawei makes a ton of money. They make more money now than they did pre-entity list stuff. The whole 14A by 2030, again, I bring out my construction stack. Construction versus urban planning argument. It's you're arguing apples and oranges on that front.
Yeah.
They've presented this just before Computex.
I don't think that's by chance.
Is this a coincidence? Because it happened at a IEEE conference that just happened to be held in Shanghai the week before. I may have even been asked to present at this.
I think you were. I think you were talking about.
Now, I know there's another one in September. Let me see if I can. Because that's a real kick in the teeth. If I should have, no, it wasn't this one. But yeah, this is the problem with IEEE events. You don't know what's going to be presented when. You go to the ones that you think stuff's going to happen. So, yeah. Is there anything else I want to get mad at? It's my big issue is just how it's been promoted. People have taken it way. People are saying this is an attack on TSMC. No, this is just one thing that it looks like if they've managed to succeed, they've done it well. They haven't answered everything, so it'll be interesting to see how they do answer those things. If anybody from Huawei wants to reach out and have a chat, bring me up. Right? Happily have a talk to understand what's going on. I don't like the fact that the paper's AI generated. Maybe I'm more angry with just the generic response to all this.
I don't know. It feels.
Now that I've actually spoken through it, I think I'm calmer.
That's good.
And my beef isn't necessarily with Huawei.
No, I think I agree that my beef isn't necessarily with Huawei. I think it's the way that certain people are presenting this.
It's everybody claims to be a semiconductor expert on Twitter. It just means that later today I'm going to be recording a video saying exactly the same thing.
Yeah.
So, okay then, let's have a mid-show break, even though we're now 45 minutes into it. I am going to bring up the fact that we have some new things in the Tech Potato shop.
Ooh.
Let me bring up my screen here. And it's all very fun. For some reason, I don't know why it's so boxed out. Yeah. No, let's go with that one. Okay. So we now have your emotional support prompt. That says, thinking longer for a better answer. A good thing to hold when you're on a when you're in a meeting. Your analog email assistant is a notepad that says "Help save the rainforests by not printing this email." Brackets powered by GPT.
Oh, I need one of those.
I thought you might. George is a notebook user. Through popular request, we have a potato hat, which is just the logo. We have a mug, the GPT mug, the General Potato Transformer mug, which is still thinking longer for a better answer, one to hold up in your meetings. And we have an unboxing of the last one. Where's my mouse pointer?
And
there we go. This, you might say, that's surprising coming from a channel that speaks about AI so much. It's it's like the dumb, sarcastic joke in the corner. We have a T-shirt that says, "Oh, my!"
If not bubble, why bubble shaped?
Yeah. For some reason, my camera doesn't look green.
That looks too much like a Pokeball. Prepare for the Nintendo Cease and Assist.
Oh, for God's sake. But yeah, it's if not a bubble, why bubble shaped? So there are a few more things coming to the store soon, but for them specifically, I want to get a sample in to decide whether I want it to go on the store. So there may be some high NA EUV socks coming, which should be fun. I actually also have a bunch of stickers that say sponsored by TSMC, but I don't think I'll ever sell those because they might get very mad at me if I do. But you can help.
It should say fed by TSMC, and then just you taking a bite of a wafer.
Yeah, something like that. But yeah, this is if you want to help support the channel, if you want to help me feed this guy over here at Computex, then please do head over to shop.techtechpotato.com and get your fill. This actually arrived in, I think, 4 days of me ordering. I've got like another $300 worth of stock on order that's being shipped. And it should be here later this week. So I might wear some at Computex. We'll see. We'll see. Okay. That was my big ranty topic.
Yeah, let's go. Let's continue with the China news. In a paper, 2 papers actually, we got some clarity on China's new their new exaflop systems. Their 2 exaflop system, or theoretical system, is called Line Shine, and the other one, it's about 1.5 exaflops, is CNIS, which has an acronym. I think it's China New Intelligence System, I think.
Wrong button.
Hello, Dom. The person behind the curtain. But yeah,
so, I'm trying to get this page out. So
yes, so
Line Shine.
Let's talk about Line Shine first, because that is the bigger of the 2. Line Shine is on paper about a 2.4 exaflop. So the R peak in top 500 terms, about 2.4 exaflops, based on what we know. Here it is saying that the power efficiency is about it's about 40 megawatts with a power efficiency of roughly 50 gigaflops per watt. But
so it should highlight that China doesn't submit its supercomputers anymore to the top 500 list.
No.
We suspect that they have 1 or 2 that are already in the 1 exaflop area.
Yeah,
but we don't know for sure because they keep quiet. The fact that they've even presented this to this level of detail in English is really surprising. And as you can see from this slide, it's all about energy scale compute, energy scale storage, performance scale interconnect. So they're leaning heavily on interconnect, and even still with that, 13 million plus cores, 90 compute cabinets, 2 exaflops of full FP64. And we're definitely sure that's full FP64, not simulated FP64.
So it is FP64, but this is not vector FP64. Let's make that clear. This is matrix FP64, which is useful. However, it is not as universal as vector FP64. So diving into what actually powers this.
If there's a specific slide you want me to show, tell me.
There's a slide. There was a specific slide. It was
The CPU core?
Yes.
This one.
Yes. Okay. So this is what's powering the line shine system. This is a ARM-based CPU that supports SVE2 and SME, so the latest standards. I don't know if it supports SME2 or not. I suspect not, but that may have to be clarified later.
Dom, do we have a higher resolution of this? For some reason, it's only 1000 by 750 in the back end, and the others are 4000 by 3000. He's having a look. I want to get a better definition of this because, yeah, those ALUs and the packaging looks interesting. Sorry, please continue. George.
Yeah, so this has matrix FP64 as well as vector 64, but that 60 teraflop number is matrix FP64, and it uses 690 watts, which is 10 times nice. And each of these, now what's interesting is that this is actually split across 2 dies, as you can see, but this is actually behaving as functionally 8 chips because this has 8 NUMA domains per package. The way that this is set up, and I have my little diagram here, that's actually in the paper, is that each die has a shared L2. Yes. Wait.
It's I'm going to bring up a picture.
That's right. Let me correct that. Each cluster, so there is 4 clusters per die, 8 clusters per package, and each cluster has a shared L2, but there's no, yes, exactly. There is no LLC here. There's no chip level, last level cache. And that kind of hurts it. So if you access the HBM within a cluster, so the cluster level HBM, as I will call it, that is up to 450 gigabytes per second to local stack. So times 8, that is 3.6 terabytes per second of bandwidth. Really close to the 4 terabytes on paper, perfectly acceptable. Now, if you go to, say, on die A, you go from cluster 0 to cluster 2, you drop down from 450 gigabytes per second to 230 gigabytes per second, which is a significant decrease in your bandwidth. So you for this chip specific, you kind of really want to optimize cache locality, and data locality is very important for this chip. And if you go to the second, if you go from cluster 0 on die A to cluster 0 on die B, that drops down to 170 gigabytes per second. So again, data locality is very, very important for this chip. Now, they're actually treating the DDR as a single NUMA node, which is perfectly acceptable because there's at the die boundary, it doesn't really matter what cluster's accessing it. It's about 125 gigabytes per second, local and within the same die. And then going to the other dies, DDR is about 110. So very similar. They're essentially kind of, you could think of it as fudging it as a single NUMA node. That's fine. That's not a big deal. And then the interconnect to another CPU is 45 gigabytes per second, or about 400, about a 400G link.
Each chip seems to have 2 of those because it says on-chip integrated NIC of 800 gig.
Yes. Why they didn't report?
I really would like this picture at high resolution because I can't see the words.
I wonder if they're doing the NVIDIA thing and they're double counting. And this
Oh.
is single counting.
Jensen math.
I wonder if they may be doing that.
So custom ARM compatible core.
Mm-hmm.
2 chiplets. Each chiplet will have access to 4 HBMs, which is then backed by a set of DDR.
So we say the thing is we say 4 HBMs, but here's the odd thing: each stack is only 4 gigs in size. Now, I don't know of any HBM
2E
stacks that are 4 gigs in size and 4 gigatransfers per second speed per pin speed. Like, so I don't know if this is actually what we would think of as HBM, or if this is something else. If this is something like a custom memory architecture that is just high bandwidth memory. And then they say, they even say it here, customize DRAM dies, reduce power and area, wafer to wafer 3D stacking combines DRAM and logic wafers. But on the right-hand side, it's not shown particularly well here because, again, it needs a higher res image. This just looks like 2.5D packaging.
Where did we get these images from?
We got Twitter.
Okay.
I can send you the original link if you want me to.
Yes, please.
Yes, sir. Give me a second. Here you go. I've put it into the tech Poutine.
Yep. Okay. Yeah, okay, this is a lot better. It must have been when we were making them JPEGs, we resized them rather than just save them as JPEG. Yeah, keep going. I'll bring this up in a second.
So it does kind of look like 2.5D packaging. Maybe there's a logic die on the bottom of the HBM, like HBM4. I can believe that, but it kind of looks like it's
an interposer.
Yeah, that's
the green. Yep, here we go. That's a lot clearer.
Yes, it's a lot better. Yeah, and then it's interesting that there are what look like 4 I/O dies. This is kind of reminiscent of Ponte Vecchio in terms of. Wait, hold on. Is that actually 6? Wait.
No, it's.
Wait a minute.
They've got their images mixed up.
No. Wait, hold on. Is this actually 16 HBMs?
Well, no. If you look at the picture on the right in the middle, it's 4 per die, which is what you said, which also goes back to the other image that we had before.
Okay.
Which is this one, which is 4 per HBM, 4 per die.
Yeah. Okay.
That's the equivalent of Intel showing off a 4 die Ponte Vecchio.
Yeah. I think it was Arctic Sound, but yeah.
Interesting here in the matrix. So each 64-bit Mac can do 4 32-bit Macs, each of which can do 4 16-bit Macs, each of which can do 4 8-bit Macs.
Mm-hmm.
So yeah, absolutely packing them in. Customized DRAM dies to reduce power and area. And then scale DRAM on top.
Yeah, that's this is the networking.
Yeah.
A 4-layer fat tree That is a lot. That's
Sorry, that's incredibly inefficient, isn't it?
yeah, it is. That's I think most factories, like at least for at this level, they're usually somewhere around a 2-layer or a 3-layer.
Yeah. Usually it's a function of size, right? Because each chip only has has 2 400 gig connections.
Mm-hmm.
It means getting your all-to-all compute. We don't have how the chips are connected, unfortunately.
No.
It's I'll need to get rid of some of these images on the back ends that we're not using anymore. We're limited to 10. We can only queue up 10. So as we're going between them all. Okay, yeah. So large scale network at 22,000 nodes, 200,000 ports, 1 microsecond hop latency. Oh, the top layer might be an optical layer.
Perhaps.
It says 4-layer network with only 1 optical layer. So,
I mean, so this is 22,000 nodes, which sounds like a lot. And in HPC, that is a good amount of nodes. But in the AI space, that's not.
no.
We're talking about 100,000 node systems in the AI space.
Well, this is 90 cabinets. How many cabinets is
So before you say the other big supercomputers from
I'm thinking about Colossus from XAI and Eagle.
Oh, butt ton.
And Eagle's small.
Yeah.
So Eagle, for those of you who don't know, I think it's still like number 5 on the top 500 supercomputer list. It's what Microsoft stood up for OpenAI, but it was only a fraction of the total build out because they had like 3 days to do it, to run the So this is the compute patterns. They want to do everything from HPC to AI, and they've done a graph of what that's like. And it looks like they've been publishing some papers to be able to deal with the workload on this in advance. Auto vectorization in the software. Memory aware data placement.
Mm-hmm.
I mean, the golden compiler is the one that knows what hardware, what ecosystem you're compiling to, right?
Where is it? Where is it? There it is.
In compiler we trust. In compiler we trust.
Yep.
So, yeah.
So it's also to note this the 32 gigs of HBM per package is backed by 256 gigs of standard DDR on the back end. So if you go back to that the CPU slide, you can see that they have the same cache and flat modes. If you remember back to the Xeon Phi days, where they had capabilities for HMC and then DDR. So yeah, that's also
wait,
an option there.
When is this machine due?
So supposedly this is already up and running.
Oh, okay.
Like this is up and running. So now moving on to the other supercomputer, the CNIS CNIS computer.
Actually, I want to. Let's see if I can share this. Remove media first. This is a top 500 list.
Yep.
Right. And we said that was what, 2.3 exaflops?
2.47.
That's our peak.
Yes.
So it would theoretically be the second most powerful supercomputer.
Yes.
At 40 megawatts, so only twice as much as Frontier, just under twice as much.
Mm-hmm. It's about the same as Aurora. It's not far off of Aurora if you think of it like that, actually.
Oh, okay. And this is also,
however, I will.
This is
say,
also this is also SMIC.
I will also say that those are peak numbers for LCAP, Frontier, Aurora, and I think even Jupiter, but don't quote me on that. I know the top three the best. Those are not using matrix numbers. Those are vector numbers.
Okay.
If you factor in matrix, that then changes. That basically should double for the AMD ones. I don't remember for the Intel one if that would double or not.
Why don't they use the matrix numbers? Just because LinPack is a vector, not a matrix.
No. LinPack is gem. It does benefit from matrix, but for whatever reason, the R peaks just aren't in matrix.
Weird.
I don't know why, but
the chips are made at SMIC.
Yes.
So Intel 14 equivalent.
We actually the Kirin, the N+3 node that has been sliced apart is roughly N6 levels, give or take.
Right.
In terms of density. Yeah. So this is likely an N6 like node, so that puts it on par with Frontier in terms of node.
Well, I was thinking more in terms of Aurora.
Aurora's N5.
Is it
for Ponte Vecchio's, the majority of the compute is on N5. Okay,
yeah. So so slightly worse than Aurora, hence why the numbers and peak flops kind of match up.
Yeah. This is
okay. Again, we are comparing vector and matrix there, so
yeah, bit apples and oranges, and in reality, because of the worse bytes to flop ratio, the line shine system will struggle with actually getting all of that performance. It's actually roughly equivalent to Aurora in that. Again, this is actually kind of a Chinese Aurora, honestly. But moving on to what I've deemed, we have Frontier at home, the CNIS supercomputer, which there's not really any. There's the paper, but there's no good diagrams. And the thing here is, the interesting thing is that the CPUs are CISC based, and the software that they are using to run the GPUs is ROCm. What this system very likely is and here's the paper, is a Hygon built system using what is likely Zen 1 derived CPUs with GCN 5 or GFX 9 based GPUs.
So RX 290 or 490?
No, this is Vega.
Okay.
Or what I've kind of deemed a proto MI 100.
Okay.
This is like CDNA 0.5, kind of.
They're also submitting this for the Gordon Bell Prize
Yeah,
at Supercomputing. Do they do that at ISC or is it just SC?
just SC, I believe.
Okay, so we'll hear more about this later in the year as well.
Mm-hmm.
But this is a molecular dynamics solver, not not other types of HPC. Now, there is one dedicated piece of silicon to molecular dynamics solutions. It's called Anton, and last I heard, Anton's been mothballed in favor of AI. The emotions of George. But saying that this isn't a dedicated piece of hardware. It's a Zen 1 offshoot of a Vega offshoot supercomputer.
So, talking about the CPUs first, the CPUs are likely Hygon XC86-4G, which is their 4th generation system, which is Zen 1 or Zen Plus based.
Mm-hmm.
But instead of a 12-channel DDR5 4800 setup, this has a 8-channel DDR5 6400 setup, which gives it notionally less bandwidth, so about 409 versus 460. PCIe 5, a clock of 2.4 gigahertz, and 64 cores with SMT2 is believed. It's 64 cores. I don't know if they said it's SMT2 or not, but I would assume that it is SMT2.
It doesn't say.
Then I am going to make that assumption for it. That is, in fact, SMT2. Their next generation, if it's SMT4, then we know that is Gen 5 base. It is not actually Zen 1 based. It is a weird custom thing by Hygon, but it doesn't say that. And I'm going to assume that this is the Zen 1 version for now, until new data comes in. The GPUs, 32.4 teraflops of FP64 vector, which ends up being 65.5 teraflops of FP32, vector, and 470 teraflops of FP16. I believe that is matrix. There are 320 SIMD units. Now, the complicated thing here is I don't know if that's actually SIMD units in AMD terminology, or if that actually means CUs in AMD terminology, because in each GFX CU or compute unit, there are 4 SIMDs, right? There's 4 SIMD units. So this is either 320 CUs or compute units and 1280 SIMDs, or this is 320 SIMDs and 80 compute units. Don't really know. But that is then backed by 64K of local data share or LDS, 8 megs of L2 cache, 768 kilobytes for the registers. I'm assuming that that's 192K per SIMD. And then 64 gigabytes of HBM at 1.8 terabytes per second. This system has 5,632 nodes, which gives you about 1.5 exaflops of FP64 vector. So this falls in between Aurora and Jupiter. So this is this would be number 4. That's interesting. That's an interesting omission that you have highlighted.
The current hardware lacks a reliable operation counter. So we enumerated every floating point arithmetic instruction executed, multiplying it by the corresponding interaction count measured at runtime, and sum across the full molecular dynamics step. We compiled the unmodified upstream branch of the GPU code with CUDA and profiled it on an NVIDIA GPU. This reports per kernel instruction counts, which we used as the ground truth for our model. So we compiled it to NVIDIA and said it takes this many flops, therefore it must mean it takes that many flops in our hardware.
No, that's no, pain.
That's how everything works, right?
That hurts me at a psychological level. At least if they had used an AMD GPU.
No. So this is the criticism that's leveled at Geekbench, right? When you compare x86 versus ARM, right? Do you want to get it compiled to target so it's the most efficient on each target, or do you want the same instruction flow?
Yeah.
Because if you've got a workload, and I'm just taking CPU for example, if you've got 3 decode units versus 5 decode units, if you've got micro-op cache versus no micro-op cache, if you've got 8 execution ports versus 12 execution ports, or mix them all up. Do you want the same codes to run through each, or do you want an optimized codes to run through each?
Ideally optimized, but
so yeah, it comes back down to tau scaling, time to solution, right? If you send the same code path through each of them, you are comparing how well the architectures do on a very specific amount of code, and you expect them all to do the same amount of operations. Unfortunately, it gets confusing when you start dealing with loop unrolls and you overflow caches, and you have to recalculate addresses.
Yeah.
Guess how many flop counts don't recalculate addresses?
Huh.
All of them.
Huh.
So it's
I did actually notice that on my first read through. I was more focused on the GPU performance and the theoreticals of the GPU than the
So the flop count, on this system may be plus minus 40%.
Well, so the flops of the GPU are the theoretical numbers, right? That should be theoretical, right? That should be.
It's the way they're counting sustained performance is the flops of the operation.
Oh, which is not even calculated. Oh God. Yeah. So this, and the thing is. Oh, that's awful. That is proper kludgy.
Oh no! This is because they wanted to evaluate strong scaling.
You don't have to do this to evaluate strong scaling.
Some physical chemistry.
Also, hello, Anshul.
Yeah.
Oh God, this hurts me. This hurts me. It's because the first thing, and Ian, you can attest this. The first thing that you are taught in, at least in physics, is always have your units. Always remember your units. The second thing that you are taught is know your error bars.
It's difference between million transistors per square millimeter and million transistors per cubic millimeter. Density.
Yeah. Huawei math, but in supercomputing land.
China math. Well, did you see Linus's video where he bought a 140 something inch TV And
Yes.
they measured it arrived and it was 130. And the response they got back was, well, we measure inches differently in China.
No. There's
This is not going to win.
no.
If this wins a Gordon Bell,
I'm gonna be on the floor like protesting this. And I know that some of the folks on that committee sometimes listen to this. Guys, don't no. The measurements here are bad.
well, the arbitrary measurement.
Yes, yeah, the arbitrary measurement.
Do the arbitrary measurements even matter?
Yeah.
If you're publishing them in a paper.
Yeah, that's yeah.
What's happened is somebody said we need to do this, but we can't because we didn't design the chip to do it. So
Nicholas says no cheese. We must hype then cope. And then Angel says they have a unique inches measurement.
Yes. The Linux inches.
Yes.
Okay.
So
Chinese supercomputers. Can't live with
Yeah.
them.
Can't live with them. Can't live without them.
Oh no! I know. I just left it there
Uh,
because we're not in China.
So moving on to AMD derived chips to actual AMD chips. AMD Venice, the mass production or the ramp, I should say, of Venice has
Zen
started.
6.
So Zen 6, AMD today, that being 4 days ago, announced that its next gen AMD EPYC processor, codenamed Venice, is ramping in Taiwan on TSMC's advanced 2nm process node, with future plans to ramp at TSMC's Arizona fabrication facility.
Arizona only does N4 right now.
Yes.
But yeah, it's just we're ready. We'll probably hear more in 2 months at Advancing AI.
Yes.
Zen 6. And if you're waiting for consumer N6, end of year?
Yes.
About that. That's what we're thinking. In other news, we have... let me see if I can grab a screenshot of this. People may or may not know that I used to be a competitive overclocker. The thing that I did in my spare time. And one of the things you do when you're a competitive overclocker is you try and run your CPUs as fast as you can. And the faster, the better. Let's see if I can share this. Stop that sharing. Share screen.
So Angel says, I was just going to say it'll all be at Advancing AI. Back to the Zen while you're getting that up.
Yep. Sorry. I'll
So
have it here in a second.
So I'm just really hoping that they don't shove us with CPUs and GPUs all on the same day, because that's going to make my brain explode. Especially with the questions that I'm going to have to generate.
Yeah.
Ugh.
Yeah. The agenda is already online.
Uh-huh.
I mean, it's rough agenda. But what I wanted my news to be is, one of the things that the holy grail of overclocking is just how fast can you get your CPU, and you need it stable enough to take a screenshot of a CPU monitoring tool. The and over the years there have been some complaints that this doesn't make much sense, and the argument is it doesn't have to make sense. This is just speed. And what you do is you take a modern CPU, you increase the frequency until it crashes, then you increase the voltage a bit, and then you see if it's stable. Then if it's stable, you increase the frequency again. If it becomes unstable, you increase the voltage. Now, because you're increasing both, you need to deal with cooling. So extreme overclockers will go from air to liquid to sub-zero solid carbon dioxide to liquid nitrogen to eventually liquid helium. And the record when I was doing this 12, 15, 20 years ago was about 8.2 to 8.6 gigahertz. We got 9 gigahertz a few years ago, and now the Chinese, in partnership with ASUS, have broken it once again. We're using an Intel Core i9 14900KF at 9206.34 megahertz using liquid helium. In the past, this was typically done on one core. They had 7 cores of this chip enabled. It's a stability thing. Some cores are better than others. Not all chips are the same. So this is the only chip in the world that will do 9.2, or at least the only one that they've tested for 9.2. And it has to be stable enough to boot into the operating system, run the CPU monitoring, and then do the validation. The thing is, you can boot into the OS at slower speed, and some motherboards will have a toggle that will instantly put it up to the max frequency and voltage. The thing is, you have to manage that transition as well, because that impulse change could cause instability. And this is what it looks like when you're dealing with liquid helium. Now, the setup for liquid nitrogen is somewhat similar, except you use thermos flasks to pour it. In this motherboard here, we've got a giant copper 2 to 5 kilo CPU weight. It's called a pot. It acts as a heat sink. And the idea is this, that you make it very cold. And the colder you can make it, the heavier it is, the more stable you can regulate the temperature. Because some CPUs will bug out at a certain temperature, so you need to keep them just above that and to keep it stable. You might say, well, this is expensive. Surely liquid helium is expensive. Liquid nitrogen is about $1 per pint. Liquid helium is about $50 per pint. The main cost, though, isn't the helium. It's this hose. You see this hose in the picture?
Yeah.
That is a single-use $5,000 hose. Now, typically, people design these sessions to run all day.
Mm-hmm.
So this may have been 4, 6, 8 hours into because behind them you'll probably have 10 different setups all ready to switch in and out if something breaks because of condensation, because you're running it so cold. And that's why there are lots of paper towels around. But yeah, the record is just simply stable enough to boot into an operating system, run that CPU monitoring tool, get the validation. And here we have, negative 256 degrees. Here's the official validation. You can see 7 cores on Raptor Lake. They had 1 stick of 16 gigs of DDR5 5600 running at CAS latency 32. They had a single 120 gigabyte SATA SSD running Windows 7. And at this point in the competition, it's just the finest of margins. So it's one of those things where sometimes it gets a lot of attention. This one really didn't. It's just, hey, it's another record. They upped it by a few megahertz. That's kind of cool. Someday we'll hit Intel. When we hit 10.
Yeah, Intel's promise will have been fulfilled after 21 years and counting.
Yeah, it's 2005, they said. So, yeah, it's going. And it's still an Intel chip. And the argument is, as we go to smaller and smaller process nodes, perhaps you can't cool it as much.
Mm.
And, yeah, these people, if they work closely with Intel, they may have got a special bin from Intel that was guaranteed to work at very low voltage at base frequency. But sometimes the best CPU just comes out of buying 100 and see what happens.
Yeah.
Now, if you wanted to run something like SuperPi or W Prime, instead of 9.2, it may have been 8.8. That's just how stability works.
So Nicholas says, I wonder how interesting it would be if we had access to the Black Ops type bins. Remember Black Ops CPUs? Do you have one?
I have many.
Ah.
I have the 14-core, 5 gigahertz auction-only one upstairs.
That's the 9990?
Yep.
Not many people remember that, Shep. For good reason.
I have the AMD Ferrari Opterons.
Yeah, those are funny chips. Because they disabled, like,
that was what
FMA.
That's one of my first videos. It was about that chip.
Oh.
I have the is a 7295 Xeon Phi, the top bin of Knights Hill. Yeah. There's a few circling around. Oh, and I have my AMD tweaker somewhere. That's they only gave out 100 to overclockers, and I eventually got one years and years and years and years later, because a friend found it in his desk, and didn't realize how rare it was. And I've got a Skull Trail under here as well. Still, or is that my Centaur? I forget. They're still in the box.
One of them. So
yeah, so I really enjoyed this because hey, it's a new CPU-Z world record.
Yeah. So sort of bookending this back to Cerebras, or back to AI. Cerebras has IPO'd.
Yep. The chip as big as your head.
Yep. And
again, I've done many videos on these people and this chip. For those of you who don't know, a chip is that size next to my head. Well, this is a package, right? Chip's a lot smaller. Yeah. What the guy's holding here is one chip, 24 kilowatts, 900,000 cores, and one of the first AI startups to go public.
So it peaked. Hold on, I'm pulling up the stock right now. It peaked at.
So they had raised. They just did a Series G of 1.1 billion for I think a market value of 8. That was last September. They currently at a market cap of 56 billion.
Good.
This is
What's the percentage? What's the term? Cash out.
Yeah. It's about an 8x. Since the IPO, it's gone down, but that's because it was so overhyped. Yeah, they hit a high of 286. They're now down at 253. Their P/E ratio is 600.
They hit a high of 386 before.
That's what I said. Yeah.
Oh yeah.
Yeah. But it does mean they now have to file quarterly financial reports. So we'll actually get proper updates on their revenues. They just signed a massive deal with OpenAI for a gigawatt of chips.
Is it an actual signed deal, or is it like a letter of intent?
Stages.
Okay.
So if you're working that out, it's roughly 40,000 chips. And so I saw one person do an analysis on it based on their public margins in their IPO filing, and each of their systems is under a mil. But that contract with OpenAI would be 40 billion in revenue if completed. And they're working on next generation chip with optical connectivity.
Okay,
good. The thing with the chip is it holds a lot in its memory, 44 gigabytes, and it's really fast on that data. The problem is getting the data in, and the fact that it only holds 44 gigabytes, which means you need anywhere from 4 to 16 to 32 chips for big AI models, but it runs them at 2,000 tokens per second.
Yeah,
and OpenAI is using it for code.
The big criticism I've heard of Cerebras is the shoreline I/O. Like, it doesn't have enough external I/O.
The problem is when you have a chip that big, right? Your DVFS of each core is different. It's the same with like an 8-core Intel or AMD CPU. The thing is, because the wafer is so big, you may have some cores in one corner at 0.9 volts and some cores at the other corner at 1.1. And so as you asynchronously push the data through, you've got to manage that. It's not so much the data in, data out that's the issue. It's just the capacity.
Yeah. I was, yeah.
It's the when you do the cache hierarchy graph of latency, the thing is that 44 gigabytes is super small for a long time.
Yeah.
And then you get a massive bump, which normally people would have at DDR. But you're talking about HBM is terabytes per second, onboard SRAM is petabytes per second.
But once you run out of the 44 gigs, you're now limited to 150 gigabytes per second external.
But if you chain chips together, you increase the memory.
Oh, sure.
Because you're only transferring cache elements across. So that's not here or there. The problem is, if you want a trillion parameter model, these chips don't support FP8, I don't think, yet. So next generation will. But it means for big models, you still need lots of data. And it's a many-core design. They've presented the hot chips many times. Andrew and the team are actually really fun to talk to. James over there, he's doing the comms and messaging. He's really fun. I haven't spoken to them much recently because they've been too busy. And the contract that got away. But no, it's fun. Maybe I'll go see them next time I'm in town. Talk to me. I'm here. I missed them at GTC because I had other meetings to go to because they had the satellite event. I'll have to make time. AMD's advancing AIs in Moscone, isn't it?
Yes.
Yeah. Okay. It's a pain. But yeah, Cerebras IPO'd. Big deal because it now means that a lot of investors are thinking about investing into other AI companies.
So, question for you: do you think that this will be a benefit for companies like SambaNova, TensorTorrent?
TensorTorrent, yes. D-Matrix, yes. SambaNova, hard to tell. just because of where they are. I might be doing a fireside chat with the Salmonova CEO at Computex. Still need to finalize details on that.
Oh, okay.
Next Silicon has got their system up and running now at Sandia. That's fully up and running. Stephen Ellis from Reuters went to go see it the other day. Funny enough, because it's in a secure facility, the CEO can't go in.
Ha!
Because he's not American. But the journalist can.
Which is hilarious, but
yeah, it's just when Grok got acquired, right? That gave a new flurry and interest into the investment community into AI hardware again. Cerebras is going to do the same thing, and arguably a lot more because the market cap is so high. You know, if Grok had IPO'd, what would their market cap have been? Would it have been as high as 20?
I don't know.
Or is Cerebras unique enough that it's just a one-off?
So, what I will say is, outside of AI, again, it will be interesting to see what they do with the optical, if they're doing optics on package, co-package optics, or even near package optics.
So I will say that at IMEX event, because one topic we haven't got to, and we'll probably get to it next time maybe. I went to IMEX event, and ASML presented there, and they were talking about using the cross reticle stitching for other people. Okay,
that's not surprising.
No, but you build it. So right now, they've had to use the EUV tools to do it, but now ASML are going to come at it from the other direction and say, well, we're going to design our tool to do it specifically. That's one of its modes.
Interesting. Actually, speaking of packaging, this is circling back to the AMD announcement. AMD announced that they're actually doing. AMD has achieved a major milestone with PTI, qualifying the industry first 2.5D panel-based EFB interconnect. So usually, as you know, chip on wafer, you're literally putting with CoWoS, you're literally making the substrate out of a wafer, out of a 300 millimeter wafer. And the issue with that is, well, the wafer is a circle, and the substrate has to be a rectangle. Panel-based means that it's actually it's a rectangle. Your wafer is not a circle; it's now a rectangle, which helps with yields and throughput and all that.
How do you grow a rectangular piece of silicon?
I have no idea.
You grow a bigger circle, a cylinder of silicon, and cut it.
Do you think that's what they're doing? Because that seems...
We typically speak about panels when it comes to glass.
Yes.
Not silicon. But...
Okay, that brings up... Oh, God, my brain just went to the Twitter.
Oh, glass core substrate.
Yeah, no. Guys.
Do you want to cover that?
Yeah, let's cover it.
Okay. So we've spoken a little bit about Clearwater Forest this podcast. Intel's next generation E-core product, due out middle of the year sometime. Was it up to 288 E-cores, that sort of thing? And we know it's chiplets. We know that it's three sets of 4. Each set of 4 has its own interposer. Then there's a global interposer. Then it's connected to memory, and you have your I/O dies and what have you. Designed for a very specific market in mind. For some reason, because glass core substrates have been on the mind of people because it's the next packaging technology, because it can deal with higher density and faster interconnects. But you have to deal with stress and strain and shear and it's glass core, right, rather than a fiberglass core. And because Intel has been the most vocal on their R&D, even them being the most vocal, it's come in drips and drabs. Some bright spark, as in some anime imaged profile picture Twitter account with a nondescript name, anonymous, maybe from Korea, maybe from China, decided to put out that Clearwater Forest from Intel in 2026 is going to be using glass core substrate as its packaging. And Cheese and I and a bunch of other people, because just like the Huawei shit went like wildfire around and nobody's checking it because nobody understands what it means. That's what happened with this. And Cheese and I and a few other people turned around and said, do you know the state glass core substrate is in R&D? Do you know how long it takes to get from initial idea to high volume manufacturing yield? Do you know how much information they would have publicized by this point if it was ready for high volume manufacturing? Where is it being high volume manufactured? What of Intel's fabs and facilities would it be done in? This is what we know. It's a 2030 plus technology at the earliest. Why on God's green earth or Buddha's green earth or whatever deity you pledge fealty to, if any, why would 2026 be the year of glass core substrate? I spend my days following IEEE conferences around the world. One thing we don't know is what exactly are the metrics we should be judging glass core substrate by, right? Is it density of connections? Is it throughput? Is it yield? Is it cost? Is it dimensions? How, all these sorts of metrics we still don't know yet because it's still really early in the R&D cycle for it. I showed a picture off of a glass core substrate without the fiberglass top and bottom because it's glass core, not glass. From I must have been a conference earlier this year, and it's literally like designated as a research project inside university. And if that's the only thing I've seen in public, how the hell are we going to get to high volume manufacturing by 2026? Mid 2026. They are working on it. Yes. It's not ready even for basic prototypes. We're going to see Intel CEOs trot it out for a couple of years before it, just like EMIB. And research papers, just look at the research papers, look at the conferences. It's just, and you just know that there's investors somewhere that can't tell the difference.
Well, it's like, because so when I made a post about it, somebody said just ignore these people. It's like, yes, but also people actually listen to this, and it's like I feel like an obligation.
It's one thing when it's brief. It's another thing when it's distracting people. Because Tom's Hardware is a sort of company that will
D's or D
Detrez.
It's not just U.S. investors. Trust me. Actually, if anything, I've had to inform more Europeans about what's happening in the tech industry than what U.S. investors are doing. So that's not just, trust me, it's not just a U.S. investor thing. Also, yeah.
I retweeted it on my profile, but maybe I can find it again quickly. Yeah. let's share this screen.
Oh, so Schmarv is in chat. Hello, Schmarv. How are you?
Windows key, why are you not working? Wow, it really isn't working. How weird.
On screen keyboard. Let's go.
So yeah, this is from March 20th. This was at OFC. This is a ceramic prototype. So we're back in the 1980s.
Huh.
And this is a glass core substrate type. Again, this doesn't have any of the fiberglass on it, but this is what it would look like inside, right?
Yeah.
So,
and it's like, if we're at this stage, if we're at prototype, there's not, we are not going to mass market with this in the next, at worst, 6 months. And I say at worst because Clearwater Forest ideally should have been out by now. It has been publicly delayed. And if we're at prototyping now, I highly doubt that they would have planned for this for a 2025 product. Doesn't make any sense.
So my Windows key wasn't working because Explorer might be in the process of crashing, as it does. I will show one other tweet. If you follow Formula One, as I'm sure some people do, you may remember a team that was sponsored by an energy drinks company a few years back. Not Red Bull, but Haas Formula One team was sponsored by Rich Energy. And the joke was that Haas didn't actually get any money because Rich Energy wasn't actually selling anything. Apparently, it was an energy drink that they sold some units in Australia. I managed to get a crate, a case
Nice.
of 24 cans. So if any Formula One content creator wants to do a joint live stream where we unbox and taste it, give us a shout. But yeah, Rich Energy does exist, and I got a pack of very cheap. Funny enough, as Red Flames. Holy crap! Those must be the only cans of Rich Energy in existence. I do know that one Formula One content creator I know did import them for like £15 a can from Australia. No. These aren't expired. These were newly made.
Huh.
So that tweet all talking about a few years ago, and Intel was working on a glass substrate chip to be released either this year or next. I know what that was a Gelsinger event, and he was just showing it off as this is in the future. We'll be working on demo chips. So it was never advertised as a very immediate, just in the same way that Intel also showed off optics. And they still have that team in Scotland, if you remember, doing CPO. Oh, I am absolutely fundamentally exhausted.
Yeah.
I think that
too.
that rant on Huawei, or the people advertising Huawei, really got me.
Yeah, it's frustrating when something interesting, right? Like what they were presenting is cool.
I just don't believe it.
No, I don't believe a word of it because it doesn't make sense. The math ain't mathin'. Just like the Dell 50%.
If we take the math away, show me how you've done 2 micron.
Yeah.
In volume.
And
show me the steps where you went from 45 micron to 35 down to HBI 9, and how you've leapfrogged everybody.
Yeah. Because it just, you're telling me 2 + 2 = 17, and I'm going, what?
It's you've skipped over some fundamental steps that everybody else in the industry had to get there. I'm not saying what you're doing is impossible. I'm saying there must have been a path to get there. I would like to understand the path. Because if I understand the path, I'll believe you more.
Yeah.
Their response, however, is likely going to be, well, we'll just come out with a chip and you'll see it then. So, all right then. I'm going to get some dinner. 9 o'clock.
Yeah.
And check my emails.
We've been chatting for nearly 3 hours.
Yeah.
I should probably go grab lunch sometime soon-ish.
I think I'll make a more metered Huawei video now. The fact that I've gone through it.
Has this helped you with
processing,
calming down, processing?
Yeah, redirecting my anger.
Well, that's good.
Or frustration.
Yeah.
So.
Oh, jeez, everything's falling down now.
My only trips to China were on Huawei's invite. So, but that was years ago. That was before Entity List. I've not really spoken to them since. So happy for anybody to reach out. Assuming anybody in Huawei can even watch YouTube
or talk.
Oh, they can talk.
Yeah.
All right then. I hope everybody's had some fun, whether you're seeing this live or in catch up. Don't forget. New merch on the store. Again, for some reason, my camera is really blotting out the green that's meant to be money. It's really blurry. That's weird. But yeah, and then hopefully we'll have some socks soon, assuming I get some and the quality is good. So, but thank you, George, for joining me.
Well, thank you for willing to have this on sort of short notice, I guess.
And so our next one will be at Computex next week. We probably won't be doing it live because it's at a really bad time for everyone. So we might just pre-record an hour and a half of our thoughts at Computex. But good to see you all. And we'll catch you on the next one,
folks.
If you like this content, there are multiple ways to support the channel. You can like and subscribe this video, and many thanks for doing so. There's also a Patreon, which gives you access to our Discord. There's a merchandise store and a newsletter, links in the description. For all of you who do contribute, thank you. You are keeping me well fed.